Yo, Chuck.
Hey, what's going on YouTube? In this video, I'm going to go over Euclid's algorithm, which is really just another name for greatest common divisor. So you can see I've got two numbers, and I need to find the number, the largest number that equally divides into both, and this would be 11 in this case, 7 in this case, and then 4 in this case, etc. So that is the algorithm. I'm going to show you two different ways how to do it. So stay tuned and let's get started. Okay, so I'm going to start with the first algorithm, which I feel like is more intuitive than the other one. So you can see I've built this boilerplate. I've got a function called Euclid. It's taking two arguments, a and b, which are going to be our two numbers. So right here. So we know that 49 and 7, the greatest common divisor of those numbers is 7. So what is the strategy here for this first algorithm? Firstly, we're going to make a while loop, and we're going to test while a does not equal b. So while the numbers are different, then we want to do something. We're going to check if a is greater than b, we need to subtract b from a. And if b is greater than a, we need to do the opposite and subtract a from b. So let me show you what that looks like. So we'll say if a is greater than b, a equals itself minus b. Otherwise, we need to set b equal to itself minus a. And then finally, we're going to return a. So what does that look like? Let's run our code here and see what happens. So you can see I was doing this before. All right. And we get 7. What if we do another number like 12? What do you think the greatest common divisor between those is? It is 1. That's correct. What if I swap the numbers? So like I had 7 here. What if I just do 7 and 49 just to see if we can break it, right? Again, it's 7. I want to actually point out how the numbers are changing during this algorithm so you can kind of see it better. So I'm going to console log out a and b just to see the change. You can see we initially start with 7 and 49. We determine that b, which is 49, is greater than a, so we subtract 7 from 49, right? So now we should be at 42. I guess actually you would probably want to put this console statement within your while loop. Let's do that and see what it returns. There you go. So there's our more accurate depiction of what's going on. But you can see b is greater than 7, so we subtract it by 7. 42 is greater than 7, and so on. And eventually you're going to land here, and then you're going to subtract another 7, and then it kicks you out of the while loop because now a is equal to b. Therefore, the while loop is no longer going to function, and it's going to return whatever a is. We could also just do b, right? Because they're the same number at this point. That should give us the same result, and it does. So this is Euclid's algorithm. This is like, I feel like the easier way to conceptually understand it. You're just kind of reducing the numbers until they equal each other, and then you know a common divisor between the two. Okay, now for the second algorithm, we're going to utilize recursion and the modulo operator. So the first thing I'm going to do is I'm going to say if b is equal to 0, return a. If this isn't the case, we're going to return Euclid, so we're using recursion, and recall recursion is just calling a function until it doesn't call itself anymore. We have to have this base case here, otherwise we'll end up running an infinite loop and crashing our program. So what we're going to do when we return this algorithm is first, we're going to swap the position of a and b. So I'm going to put b here, and then in the original b position, which is right here, I'm going to put a modulo b. So what essentially is happening is I am swapping b and then I'm putting a modulo b. The modulo operator is just going to reduce a by the amount of b evenly. So if it's not even, it's going to leave a remainder. But then you'll notice how we're swapping these positions. So if there's a remainder, this result here is that, and then the next iteration is going to be in this position. And you're going to repeat the process until B, which is these values right here, equals 0. This is kind of intuitively a little confusing, I think, but it's doable. Let's run it, and then let's see if it still works. So I'm going to clear this and then run the code. And we get 7. Let's swap the positions of our two numbers just to try and break it. So let's put 7 and then 49. Let's do some weird numbers. Like let's do 787. Let's try that. So the only answer we get out is 1. We can console log A and B again to see what's happening and see a better picture. So let's try that. So if I run this code now, you can see I spelled console log wrong. Okay. All right, so let's deconstruct what's happening here. So our first iteration, we start at 787 and 49. We swap the position of 49, which is B, and we put it in the A spot. Then we take 787 modulo 49. When you run that, it equals 3. And then we just repeat the process until we realize that 3 modulo 1, or sorry, we keep swapping the positions, and then we modulo out, and then we eventually hit 0. And then when B hits 0, we return A, which is 1 again. So we know we're just at 1. What if we try to do something that's, let's do like 200, and let's do 5. That's easier. So again, this algorithm is a little more confusing conceptually, but it achieves the same thing as the original Euclid algorithm I showed you. So if you ever come across like a LeetCode problem that's greatest common divisor, this is the algorithm to use. So if you enjoyed this video, please like and subscribe. I will see you guys in the next one.